When you apply a modifier to a view, you are most of the time making a new view that wraps the original with some extra behavior or styling. Now I know I've said this a few times, but it matters. It's not always the case though. For example, text. There are a whole bunch of modifiers we can apply to this text that are applied directly to it rather than making wrapped views. For example, I could say text hello world in a font of title, in a foreground color of red, in a font weight of black, and on tap gesture to print type of self.body. And when that code runs, you'll see I can tap this button and out comes modify content with text plus the gesture. It's just literally the text. All three of these, font, foreground color, and font weight, get collapsed down. It just silently absorbs all the modifiers into itself to produce text. This is what allows us to create complex text with various fonts and colors, then use operator overloading to bring it all together into a single text view. Now you can see this for yourself in the SwiftUI interface file. If you run the xed command here, and then do Command F and search for internal var modifiers, you're going to see this is actually the text struct here we're working with. Boom, it's a text view. And these are the modifiers you can take, like colors, fonts, italic, weight, kerning, tracking, baseline, and so forth. And they all get stored in the internal var modifiers, this thing here. Boom. The text itself has an array of modifiers internally that store particular parts. So you can see there's an enum for the modifier, there's a weight modifier that stores as an associated value the weight to show, or the font to show, or the color to use, and so forth. This is exactly, by the way, how text views have different natural sizes when changing the font. You know, the font gets absorbed directly into the view and it's used as part of the size calculation. So the text always knows how big it should be for its text with its font. It gets baked into the font rather than wrapped around a new view around it. However, there are a whole bunch of modifiers that are more complex because they propagate changes downwards into child views. And SwiftUI does not mark these out very clearly, or indeed, as far as I know, at all, but you can see them in action if we just modified our code a small amount. So let's take out some code here. Let's say these two can go away. And I'm going to wrap my text view in a VStack like this. And then apply the font and the tap gesture to the VStack. So now we have title, this thing here, this font title here, on the VStack rather than on the text. And the resulting type will be different. I press tap, boom. All sorts going on now. And you see there's now an environment key writing modifier with an optional font inside. So we have this font modifier doing different things depending on where it's attached. It's attached to text or attached to anything else. And this dual behavior of the font modifier is possible thanks to Swift's approach to overload resolution, which really boils down to the most constrained overload wins. In case of our font thing here, look at our interface file for Func Font. You're going to see there is a font modifier here on SwiftUI view generally. All views get it. And there'll be a second one for font on text. So we have font here on this text view. And as a result, we have two methods of the same name, the same parameters, blah, 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 but the text version is more constrained than the view one. You know, it's text, which is a concrete implementation of the view protocol, which is more specific. And so when we call font on some text, it'll use that version here, the custom one just for text. But use it anywhere else, we'll get the view.font instead. But if I go back to the view one up here, this is the view code here, and this is the func method right now. You can see exactly how it works, right? You can see what it's doing here. It's marked in lineable, which means that Swift has the option of replacing a call to font like this with the actual body of the method. It literally copies this thing here into the code of our work. So it becomes this instead, dot environment that with the font we're choosing. So, large title, whatever. It copies it across. Now, obviously, in order to copy the code across like that requires Swift to have access to the copy of the code, the stuff here, which is why we can see exactly what SwiftUI is doing. It's got to be right there so it can be inlined. And you can see what it's doing, making an environment modifier here. And if you want to, I recommend you do look at this. You could just look for something like, just search for this, more or less. Command F for that. You'll find a whole bunch of other methods implemented exactly the same way. Just inline code you can go and noodle through and see what it's doing like that, which is pretty cool. Anyway, so we've now got that code there. So we've got two different results for Func Font, depending on whether it's the one on view or the one on text. And when it's text.font, which is this one here, this is the text code here for font, then it gets absorbed into the text itself, into that internal array of enum values. But for all other views out there, it's merely syntactic sugar. It becomes this one, the environment font, which, as you saw, gets converted into the code, copies it across like that. And the question is why? Why do we have the two options here? And understanding the answer really is the key to understanding the way the environment works in SwiftUI. This approach, the SwiftUI.view font method here, allows the view modifier, the environment of font, to flow downwards through all child views of our VStack, rather than just being applied to a single view. That means in this kind of code here, we are adjusting the font of everything inside the VStack at once, even without the view internally realizing it was happening. And the power of SwiftUI's environment is that it flows downwards to every view contained in wherever you apply it, but only views only have to read a value if they care about it. So we can set a whole bunch of environment downwards. It can mostly be ignored, but the font size, I care about that one. Let's use that. Now, to demonstrate this, we can make a simple text field that understands the concept of a required field by showing a red asterisk next to those required fields. This takes at least 2 steps for every new environment piece of data you want to add, called an environment key. First, we're going to make a new struct that conforms to the environment key protocol, which requires you provide a default value for times when there's nothing in the environment that's been customized. So we'd start by saying struct form element is required key, which is the environment key. And our default value will be false. So by default, unless you said it's required, it's not required. Second, we're making an extension on environment values, telling the system how to read and write that setting from the environment. So we'll say extension environment values var required is a bool. And when I read it, we'll just do our self form element is required key.self, get that value back, and to write it, again the same thing, but assign new value to it like that. So how to read and write, self, not set, self. How to read and write that value from our environment. Boom. And now we can go ahead and use it, right? For our text field wrapper, this means using add environment /.required to read that required key out from the environment, and then just create the view as normal. Add whatever you want to add to it. So I'll say there's a struct here called a requirable text field, which is a view. And then we'll do add environment /.required. Is it required or not? The title for our field will be a string. We'll do a binding for the text itself, so it can be read externally. Then we'll make our body here, some view, with a H stack inside, so we can have the text field and the required star if needed. We'll do a text field showing title text bound to $text. And if we've been asked to be required, do an image with the system name of the asterisk. Oops, daisy, asterisk. In an image scale of small, and a foreground color of red. So it stands out neatly. And now we can just go ahead and use it. Any way you want to have it, just send in the required value whenever you want, and it's away. So we could say in our content view, at state private var first name is an empty string. Then down here, I'm going to say we've got a form with a requirable text field here. Title is first name. Text is $first name. And then I'll post into there the environment value of required being true, like that. And you're going to see over here, we've got first name with a nice red asterisk to the side of it, as expected. Now, earlier I showed you how the view.font modifier, this thing here, is just a wrapper around the environment modifier posting in font of whatever font you want to choose. And honestly, this is good practice. It makes our code easier to read. No one wants to have to write this kind of thing. And so it's a good idea to add view extensions to make that kind of thing clearer. In our case, we would say extension on view, func required, make required is a bool equal to true, return some view. And that would just say add the environment of required to be make required, like that. And with that in place, it becomes easier to think about our code. We can now say this thing, you are just required. As you can see, I've made this Boolean parameter have a default value of true. I think it makes more natural sense to say required as meaning required true, because that's what required means, right? These two should be the same thing. Anyway, we're now applying the required extension method here to the field directly, which is fine. But you might think, well, here, the environment approach isn't helping much. Why not pass it directly into the requirable text field and its initializer? Why do it there? And the answer is that it's going into the environment, so it flows downwards. If we add more complex code like at state private var last name is an empty string, and then we'll also add at state private var make required is false, we can now add multiple text fields. We could say as another requirable text field, title will be last name. Text will be last name. I'll add a little toggle as well saying make required is on bound to make required dot animation. And now we can send in that make required value into the whole form. Like required, pass in make required. And you'll see right now this first name and last name have nothing attached to them. Let's toggle at the bottom. If I toggle it on, actually run it the SMS to be a bit clearer and bigger. Tap it on, boom, in comes the stars for both at the same time. So it flows downwards into the form, into the things inside the form. So the whole form gets required at once. It just flows downwards into each text field automatically. There could have been a different subview entirely. It doesn't matter how deep they are in our view hierarchy, right? It could have been a group, then a who knows what. It would still have access to the same data. It still flows downwards through everything. At this point, I would like you to try and make a custom environment key yourself. Ideally one without my help. I'll give the answer afterwards, of course, but do pause the video. Your goal is to create an environment key that stores the stroke width for all the shapes you want to draw. Go ahead, have a go, store stroke width, the shapes inside you want to draw, and then I'll add my solution shortly. Do pause the video, you will learn more. Okay, I am believing you. Let's have a go and see what we get on. First things first, those two steps that are required, adding the environment key and the environment values. So I'll do it after my extension here. So we'll say a struct called stroke width key, which is an environment key. And my default value will be 1. Next, we'll say as an extension on environment values with a stroke width, double being read and written. When we're reading it, we'll do self stroke width key dot self. Read that value out from the environment. And writing it, we'll do self stroke width key dot self equals new value, like that. And then you don't have to, but it's a good idea. Add a view extension, make it easy to use. So we'd say something like func stroke width. Width is double, some view, and then just send in the environment by hand here. So environment, stroke width is that width. That's it. And now you can go ahead and try it out. You could say something like struct circles view is a view at environment, let's do / stroke width, var stroke width. And then our body, we could do for each 0 to 3 underscore in circle stroke in red line width of stroke width. So every shape we're drawing, read that width from the environment so it can be controlled globally. And now just create that value at some high point in the environment. For example, I could say in our content view, at state private var slider value is 1.0. Then make a VStack to store our views with a circles view inside. And a slider, the value bound to slider value in the range of 1 through 10. And then send in for the whole VStack the stroke width of slider value. So hopefully you can see we've got these skinny little circles and a slider at the bottom. And I drag this upwards, they'll adapt automatically to be drawn thicker and thicker based on that external environment data coming in of how thick to draw our circles. So you can see how this environment works. So what I would say is we're going to do some more work in this shortly. So please do keep this whole stroke width stuff around for the very next video.